morning, everyone, and thank you very much for joining us for today's webinar, Addressing Load Management Challenges for the New Load Profiles of Energy-Efficient Homes. My name is Felix, and I'm the webinar coordinator at the Continuing Education Department here at the OAA. We will begin today's webinar by acknowledging the land on which we are meeting and calling in from today. For millennia, the place we call Ontario has been inhabited by Indigenous peoples and nations who have been stewards of the land and are deeply connected to its rich cultural and natural landscape. We would like to invite you in a moment of reflection to acknowledge our shared responsibility to address past and present injustices and provide space for Indigenous knowledge and worldviews to shape the architectural landscape of Turtle Island. Before we begin, I would also like to share some important information to ensure an effective and professional webinar experience. Please be informed that this session is being recorded for quality and educational purposes. In order to maintain a stable internet connection, we have muted all participant microphones and disabled video feeds. We highly encourage engagement through our question and answer window. Feel free to submit any questions into the Q&A window that you may have for our speaker. These will be addressed in the designated question and answer period at the end of the presentation. Kindly note, the chat function will be deactivated following this introduction. For those seeking continuing education learning hours, please note that the attendance is crucial. A minimum of 80% attendance is required for these hours to be accredited to your transcript. Please allow up to a few weeks for the processing and reporting of these hours. And lastly, please note that the presenter does not provide insurance, legal, or practice advice, and the OAA does not bear responsibility for errors or omissions in discussions during the webinar. For accessibility, we provide automated closed captioning service available in multiple languages to accommodate the needs of our diverse audience. But now I'm excited to introduce our speaker for today's session. Please welcome Tom Davis. Tom, let's turn it over to you.
Thank you very much, Felix. Just do a quick sound check and hopefully everybody's hearing me and able to view my camera for a moment until I rearrange the screen. It's my great pleasure to speak with you about this topic. Just to give you a little bit of background, I'm a climate expert, I'm really happy to see some nearly 300 attendees for this course, and I understand and I'm quite happy that some of this training is actually mandatory through the OAA. So that's as a professional engineer, our organization is PEO, and we do have continuing ed requirements. They haven't started to break it out specifically for sustainability. That might be a really good idea for engineers as well. But if
I'm sorry, Tom, I think you are still muted.
Thank you, Felix. Yeah, somehow the system decided to kick me off there and let me get back. And as I was about to say, get my screen organized to be shared here. Here, that seems to be working. All right. So I'm hoping that you see a screen now that says electrification and grid interactive technology. That's the title that I've chosen for today's presentation. Assuming everything's good out there, I'll go ahead and launch into the presentation. I'm really pleased to be here today. Just kind of very quickly, a little bit about myself. I'm a environmental engineer. I've been practicing environmental engineering through my own engineering firm since the early 90s. Been a college professor for 15 years now, deeply ensconced in research. And this past 9 months, I've actually been on a sabbatical working with the federal government and Natural Resources Canada. And I'm working on really a national training agenda to not only do training much like today for professionals practicing in the field, but also to bring that professional training down into the colleges and universities so that you don't have to, wait until you're in practice to start getting the message here. I'm a dual citizen, US and Canada, and I practice across North America. And I also work on the Climate Reality Project as a member of the leadership team, and the CEO and president of that organization is former US Vice President Al Gore, Nobel laureate. So what are we going to do today? Well, we're going to talk all things electric. I'll caution you, and I'll put one of those disclaimers up front, much like Felix did, is that I am a professional engineer. My discipline is civil engineering. My job is saving the planet. The good news is saving the planet is a team sport. That's where each and every one of you 300 trainees today come into play. So hopefully you can start practicing sustainability measures in your field of choice, architecture. So we'll talk a little bit about the basics of electricity. We're going to look at the grid, kind of the challenges on the grid side, which are monumental, as well as the challenges on the demand side, where we're adding 5 million new homes, tens of millions of new electric vehicles, and transitioning all homes in Canada to be energized by electricity. That only works if at the same time the electrical grids are going through the same process and cleaning up the emissions related to grid electricity generation. We'll take a quick look at that and sort of the state of the nation, state of North America. And, I'm happy to say here in Ontario that our jurisdiction isn't really leading the pack, but we're not at the back of the pack. So that's the good news here. So we'll talk about what those implications are for each and every one of us. Again, I'll remind you, saving the planet is a team sport. And we'll also look at some new tools, and also with my work with the federal government, just this week, we've published 7 new wall guides for new low energy wall assemblies for either new construction or deep energy retrofit. So time allowing, I might take you through that quickly. So I call it the Wild West. I found this image online. I thought it was fairly appropriate for the conversation today. And the title of this Remington image is On Guard at Night. And that's kind of what I feel like. I feel like I'm on guard at night, trying to do everything that we can to stave off, whatever the wilds are going to throw at us, to not only survive the next day, but survive in perpetuity. This image always gets me thinking about our planet. This is the first image taken by a human being. You can see in the foreground is actually the moon. So the date of this image is December 24th, 1968. And Apollo 8 was the mission. It was the first mission to the moon. It was not a lunar landing mission. It was there to scope future landing sites. But I wanted you to share sort of the excitement of the moment. Al Gore was kind enough to track down the audio between the astronauts at the moment that this photo was taken. So I wanted to share that with you to help you put this in perspective.
That picture over there. Bird coming up. Wow, that's pretty. And I'll take that. I'll judge you. Get a color film, Jim? Hand me a roll of color. Oh, man.
So for those of you that may be a little bit younger, we did have both color and black and white film back then, and they wanted to make sure they got a color image for obvious reasons. And they're joking, don't take that picture, it's not scheduled. Apparently they had a very rigorous schedule throughout that mission, but thought that, and what I like about this image is when we look back at our home, the blue marble, we call it in the climate game, is that we're really an island, and we're all inhabitants of the same island in space. On that island, every day, we're adding 162 million tons of carbon dioxide into the atmosphere, the air we breathe. Here it's referred to as a thin shell, and also refers to treating it as an open sewer, and that's pretty much what we're doing. Imagine if these were all effluent pipes dumping into the ocean, as an example. This ocean happens to be the air we breathe. We have a term for that. We call the atmosphere that we all share as the thin blue line, as reflected by this image. And when we think of the thickness of the atmosphere on our planet relative to the size of our planet, it's equivalent to the thickness of a skin on an apple. So we're jamming 162 million tons of CO2 into that space. You might say, so what? That made its way onto the agenda. So what, Davis? Well, what that means is that we've had a exponential increase in the emissions of CO2, virtually all caused by the combustion of fossil fuels. And here you see from the beginning of the pre-industrial revolution in 1850s, from billions of metric tons, basically 0 to 162 million. I thought it's also important to look at sort of the daily breakdown of those primary energy uses by source. And you can see that here in the center of this image, maybe I'll get my little telestrator going here today. And just identify here on the right, we have coal, oil in that pinkish color, natural gas in the purple. So these being basically the carbon-based fuels. Suffice to say, you don't need to be a mathematician. You can see that those make up a lion's share of the generating sources for electricity on Earth today. So when we look at 162 million tons, it doesn't really say a lot to the human brain, but when you tell humans, if you could imagine a first generation nuclear bomb, like one that was set off over Hiroshima in World War II, and then if you could imagine 750,000 of those detonations happening every day, for every day of the year, for every year from now on, it gives you an impression of the amount of additional heat added to the system directly related to CO2. Guess what? A big part of this talk is looking at sources of CO2. As we have just determined, a large source of CO2 is actual generation of electricity. So what does that mean to our grids? Here from the Canadian Climate Institute, we need to have bigger grids, we need to have cleaner grids, and we need to have smarter grids. Why do you, as individual practicing architects, need to understand this? Because at the same time, we're taking on a monumental challenge to retrofit here in Canada over 16 million homes to begin with, and 500,000 office ICI buildings. We retrofit those to net zero. The same time we're doing that and reducing the demand on the grid, guess what? There's an increased demand on the grid. We'll take a little bit closer look at each one of these aspects. So starting with the bigger one, we've got to go, as it says, 3 to 6 times faster than what we're used to doing here. 2050 is the date, by the way. That's the United Nations promulgated in Paris in 2015, that 2050 is the date that we want to be completely transitioned away from the use of fossil-based fuels, i.e. carbon emissions. That's not Justin Trudeau, it's not a Canada thing, it's a global thing. 196 nations on Earth have signed on to that accord, so it's not Canada's fuel tax, it's the global fuel tax. And what that really means is installed capacity, we're more than doubling it. Let me get my little telestrator dialed in here. So 2.2 to 3 times larger than the grid today. While we're expanding this grid, we need to shift to more renewable energies. And here you see on the high Reduction side, by 2050, if we rely heavily on solar and wind to make up major components of our power requirements, we can depend less on our base sources. Here in Ontario, our base energy is mostly or entirely nuclear. We have some renewables, but when there isn't enough nuclear there and the renewables don't top it up, we spin up natural gas fired plants. We spent billions of dollars constructing natural gas plants. We decommissioned 2 coal-fired plants, only to subsequently find out that natural gas is actually a dirtier fuel than coal. And the reason that it's dirtier is because of all the fugitive emissions, all the leakages from the transmission pipeline process to your home or to your business. Grids have to get smarter, both on the grid side and on the demand side. So here you see the folks that what we're here going to be looking at today, the demand side, what you're going to be plugging into the walls in your homes, the equipment that you're going to be running there. We're going to talk about storage solutions. It could be thermal storage, or it could also be electric storage. And grid solutions, we're not going to look at in a deep dive, but we want to talk about in general what needs to be happening there while we're doing our complete transition of the planet as we know it. So these, this is basically the grid, the supply side, and then the demand side, and maybe the storage falls somewhere in between or a combination of the two. This grid, I like how it shows sort of transitioning away from fossil fuels. The 2 big ones are gasoline for our hydrocarbon-based fuels for our automobiles and transportation, and natural gas used predominantly here in Canada as a means for heating, especially during our winters. We can see that very little of our energy mix, less than a quarter of it in 2020, was made up of electricity, whereas by 2050, let's call it all, we'll still have a couple of old gasoline vehicles running around and a few archaic pieces of maybe industrial equipment that will be operating on natural gas. But for the most part, by 2050, in order to have a planet at the end of the century, we need to get rid or stop using these fossil fuels. So that's referred to as the big switch. There's a dividing of the responsibilities, fortunately, because there's a lot of work that needs to be done. I'll quickly run you down the federal side. Again, I'm not expecting a lot of people in the presentation today are actively working on this. If you are, that's fantastic. And I'd love to sort of have a more fulsome discussion about exactly what it is that you're doing these days in your daily practice. As I said, I sort of jumped over to the dark side, to the federal government for a year to step back from teaching, to pick up what we can move out into society. By the way, much of the learning I'm going to be sharing with you today comes from the federal entity that I've been embedded with here for 9 months. So on a federal, we need to strengthen the electricity sector. We've got to drive it with climate policies. We need to, sound familiar, convene with others, right? Get together, financially support the integration. I'm happy to say the government of Canada is doing that. And they're also investing in the system infrastructures. Provincial territorial responsibilities across Canada is to have policies that align to net zero, and by the way, that align to the rest of the planet. 2050 is what I'm talking about. We want to address any sort of barriers for interprovincial commerce. And in a little bit, I'll show you the electrical generation maps instantaneously, what's being generated where in Ontario today, and exactly what those emissions are that are related to that electricity generation. We need to spend money. We need to spend money to make money. We need to spend money to save money. We're here for climate, right? So this has to be part of the solution. It gets embedded in everything get used to it or get run over by it. And then these comprehensive plans. So we're doing comprehensive energy plans on the demand side. At the same time, on the supply side, the grid is doing their own transition work. I attended a conference several years ago, and one of the speakers came up with this saying, "It's warming, it's us, we're sure it's bad, and the good news is finally that we can fix it." I'll suggest to you every sort of challenge, every global challenge, every architectural challenge that we're here to talk about today is solvable. And I'd suggest to you that virtually all the solutions we need already exist today. That's why it's so important that we gather in numbers in each and every discipline. I've been training the professional engineers over the last few months on these important issues. Okay, so when we look at our industry, 37% of the global emissions are tied to buildings and construction. By the way, that's what we all do for a living. So we can't possibly, we, the planet, can't possibly get to zero emissions unless the engineers and architects everywhere on the planet get it and implement the changes that we're about to talk to you about. Here's a little video put together by United Nations, just addressing the climate emergency and a new future. Sorry about that. And they're mentioning of every fraction of a degree. The goal, by the way, for 2050 is to make all efforts to strive to keep the average temperature increase on the planet to less than 1.5 degrees above the pre-industrial average, 1850. Over the last 12 calendar months, we've averaged over 1.55 degrees. So we've already overshot our global target. Doesn't mean it's too late. It just means that, you know, the urgency is now. And I'm also going to introduce yet another topic as we move to construction, renewable energy, and what we do on the demand side is that we have to remember that every piece of equipment, every 2x4, every piece of sheetrock that we have manufactured and installed in a building results in more carbon being added to the atmosphere. And we refer to that as the embodied carbon. I keep referring to my telestrator. So this little pen-like device was manufactured somewhere and transported to a store near me. The emissions to produce this pen and get it to me are in the air for 150 years after the pen is manufactured. What we do when we go out and change all buildings on Earth to run on electricity, ideally renewable energy, that if we go out and buy a bunch of high carbon intensive materials to do that, I use a medical analogy. If you imagine that our planet is a patient on life support, and we're the surgeons and we're going to cure that planet, we need to make sure that the cure itself doesn't kill the planet. So the materials that we use to transition the entire planet matter more now than ever in the past. This is a 1-minute video. It's the premier of Alberta. And it's kind of ironic, and this was just within the last month, that she made this declaration that it was the renewable energy sector that was the cause of the problem. So give me just 1 second and I'll get this dialed in.
Just 14% of Alberta's power generation. Premier Danielle Smith is blaming renewable energy.
We have created a structure that gives priority to wind and solar. And when wind and solar don't materialize, it takes a couple of hours to power up our natural gas. We've built the system completely backwards.
Marie-France Samarodin with ISO, the province's electrical system operator, says several natural gas power plants were already down for maintenance when another unexpectedly went offline. Plus, wind generation fell short.
We can't control the wind and the sun. And so we do our best to forecast and have mitigation measures in place.
In this case, mitigation meant rolling blackouts, affecting the entire province for about 25 minutes. It's the second time this week ISO has had to issue a grid alert, and it comes at a time when Alberta is pondering its energy future and the role renewables will be playing. Terry Reith, CBC News, Edmonton.
Well, I have my screen or my web browser in front of you. I'm going to show you this website. So this is called electricitymaps.com. It's one of the slides coming up. I have my pointer above Ontario, which is this, I'll call it a sort of a lime green color. And the pop-up window that's moving around with me, you'll see on the left-hand side, that's 131 grams. So that means that 131 grams of CO2 are emitted into the atmosphere for every kilowatt of power generated in Ontario at this moment, or as of 8 a.m. this morning. And at 8 a.m., 76% was low carbon, 43% of the makeup was renewable. And we can go into more detail and we can see how much nuclear was 32%, wind was 16%. But the irony here is in Alberta, their gas plants broke down. So somehow it was the fault of the renewables. I thought that was kind of comical. So Ontario, fairly green grid. Look at just across the border from where I am in London, Ontario. Michigan is 500 grams, 5 times dirtier, almost, or 4.5 times dirtier than the jurisdiction. By the way, the pollution blows from west to east. So southern Alberta gets to breathe the air generated by all these dirty electrical generation facilities in the US. Quebec is one of our cleanest and right now is operating at 39 grams. And I can zoom out here a little bit and give you an idea. Our friends out in Alberta that are blaming renewables for the problem are almost 4 times as carbon intensive as we are here in Ontario. And then BC is another greener jurisdiction. And then I think of these as export technologies for all of us that do work across North America. All of these grids need major overhauls. Look at this one in South Carolina. Almost a kilogram of carbon per every kilowatt hour of electricity generated. That's, insane. Okay. And then just while we're on the website, and I'll come to these slides in a moment on my PowerPoint, here's a map of Canada. And so what we can do is we can pick anywhere in Canada. I'm in Southern Ontario in London right now. So we can look at the weather in London. So the past weather, 76 to 2005, and the number of 30+ degree days that we had in that time frame was 12.5. From 2021 on to mid-century, we're nearly tripling the number of plus 30 days. And that's with climate change wreaking havoc on the planet. We can make an estimate using less climate change, and we still nearly triple the number of days plus 30. By the way, 2050 isn't that far away. Many of the mechanical systems that we're installing in our buildings today need to operate in conditions that in this case are 3 times more hot days than we're currently experiencing. We can also take a look at cold weather and very cold days. And you can see, ironically, we don't have any very cold days in the future. Why? Because the planet is overheating. That's not all good news. Heating, by the way, is the #1 killer, air pollution killer on the planet. And we can see here in London, Ontario, we're expecting a 2-degree increase. Little hint, the planetary average temperature, we look at the equatorial temperature. Temperatures are changing in the north, which Canada is in the north. We're warming up twice as fast as the planetary average. And as we move to the poles, they're warming up 4 times the planetary average. And then finally, I'll just stop on the precipitation slide here, and we can just go heavy precipitation days, stay, let's say, roughly the same up 2.5 days where we have more than 10 millimeters of rain. So I find those as kind of really good design tools to read you into the future. It's no longer useful looking at historical weather patterns to predict what's happening in the future. We need to actually predict what's happening in the future. We're not here to teach math today. One of my colleagues at NRCan has just defended his PhD thesis, and they like to talk like this, okay? So emission factors. I just showed you emission factors for electrical generation across Canada. So how many emissions, how many grams or kilograms or tons of CO2 equivalent end up in the air that we all breathe to generate every kilowatt hour? And so here for electrical generation, the total greenhouse gases from all the generation divided by the total amount of electricity generated gives us our emissions factor. So again, emissions factors for across North America live are available to us at literally the click of a button, as I demonstrated, as are the climatic conditions for Canada. Unfortunately, this map doesn't reach into North America. I'm sorry, let me rephrase that. Doesn't reach into south of the border states. They're grayed out. Even west of the border states like Alaska aren't shown in this. I'll mention my friends in the federal government are also developing similar tools to look at adaptation strategies for construction across Canada. You know, are we more prone for hailstorms, winds? What about forest fires? What about death due to high temperatures, plus 40-degree days? Those sorts of things are all important, but we're here to talk about electricity in the grid. So Natural Resources Canada is directly involved with that. And here are some of the software tools specifically developed. We call it HTAP. I'll show you a little bit of these analysis. CBAT is a cost benefit analysis tool. And you're going to see some results from these programs that have been run on a batch of 500 homes that have been recently built in the GTA. And this final tool is a materials carbon emissions estimator. And if you were here for my last training with the OAA, you would have been introduced to that tool. All of these tools are free and available to you through Natural Resources Canada and the LEAP team, and that is LEEP, Leaders in Energy Efficiency Partnerships. Okay. Peak loads. So what the heck is a peak load? All right, I always think of, mountain range, and this is the peak of a mountain. So if we're using electrons, there are times of days when we use more electrons than other times of days. Those times of days where we're using the most electricity are referred to as the peaks. Our generating plants need to supply energy to meet the peak demand, or you start having blackouts and brownouts like they're having in Alberta. Okay, that makes sense. So what if we, on the demand side of the grid, said that instead of taking the peaks to where they are, let's call the peaks today are at 100%. What if in the future we could limit the peak that we're drawing from the grid to half of what we're currently drawing from the grid? You know what? The grid just becomes twice as big. Remember, we have to double or triple the size of our grid in 25 years, let's say. What if we reduce the demand on the grid? Boy, it would be easier to double the size of the grid if the demand is halved, okay? So in this workshop with municipalities in the GTA that we looked at, they're adding over 3 million homes here in Ontario. We're moving from internal combustion engines in our automobiles to and a home that has a natural gas or propane furnace to an all-electric transportation network and an all-electric conditioning system for our buildings. The enabling technology there, cold climate air source heat pumps, which will come up later, especially when we look at cost implications for making these changes as we transition to an entire electric home. Doesn't mean putting in electrical baseboards. It might in some instances, but more often than not, these air source heat pumps are generally 4 times more efficient, 3.5 to 4 times, I'll say, more efficient than natural gas or conventional electrical resistance heating. So this next bullet point over here says, well, the grid just can't get there fast enough if we switch everything over, and we need to be more or less half of the way there in the next 6 years. So that leads me to the final bullet point. Geez, wouldn't it be nice if we could start doing some stuff now? And so if we go out and buy an electric vehicle and we have a 100 amp service panel in our home, we have a choice. We can tear out the 100 amp service panel and put in a 400 amp panel at, cost of thousands of dollars, or maybe we can limit the demands on our existing panel so that we don't have to tear it out of the wall, spend money, generate carbon to bring a new one in, and obviously the increased cost to install it. So this is a publication entitled Grid Implications of Electrifying Residential New Construction, issued last October. And, I picked out a couple of the main sort of topics in this report. First and foremost, we should not delay in the broad pursuit. So thank you all for signing up today. You're not delaying at all. And electrification is possible and happening today, and we can manage it. And I can tell you, I have good friends in BC Hydro. We can learn a lot from what's been done already in Canada. I refer to it as the left coast. I know this is for Ontario, but you know what? We can talk to those people and share ideas, and I do that on a daily basis. Governments, who would have thought governments could actually be helpful? They can enable these utilities and regulators to build this capacity. And by the way, they drive codes such as national building codes. NBC 2025 is going to be looking at operational carbon in buildings. NBC 2030 is going to be looking at embedded carbon in buildings. Okay, so, and also they can incentivize some of these changes. In the old days, I grew up in the US and in California, when they needed to build a new power plant, instead of building a new power plant, they offered to buy everybody's refrigerator that was more than 5 years old and pay them $500 for that refrigerator. And the utility, the reason they did that, it reduced the peak energy demand by running old refrigerators, which are many times less efficient than modern refrigerators. By reducing the peak, they didn't have to build a new power plant, and they saved money by not spending money, giving it back to their customers to save energy. Wow, what a crazy thought. If that worked in the 70s, it could probably work today. So we're here again as non-electrical engineers. I'm assuming most of us fall into that category. So when we talk about electricity, we're generating somewhere. maybe on the roof of your house. I might as well talk to you now. My broadcast studio, my cottage where I'm coming to you from is on a 50-acre farm. And this home was built in 1999, and it has never, ever been connected to any sort of transmission grid. The electricity that I'm broadcasting to you today is coming from sunlight that you can witness over my shoulder. And I've been doing that for over 25 years now. So we transmit this, and generally we lose about 10% of the energy just moving it down the line. And then we need to step the power down from high voltage to lower voltage, and then again down to lower voltages. So ultimately it can be consumed in the distribution system. This system has always been a push technology, a one-way street. So, tech, we call those push technologies. What happens if I'm a customer and I put in a solar array? All of a sudden I could be pushing electrons the other direction. Then this technology, the last 150 years being push technology, has to become a push-pull technology. And that means spending money on the grid side of things. Naturally, the grid operators don't like spending money, and they almost see this as an additional cost. I've met with Ontario Hydro years ago talking about electric vehicles. And their response was, you realize every electric vehicle is like having another home connected to the grid? And I'm going, well, where on earth would you find an industry that complains about doubling its customer base, especially when you're a monopoly? I don't know. I'll just leave that out there. I like to raise questions as well as answer them. And then one of the conclusions here is electrifying new construction is not a question of physical impossibility. It's a question of time. And I say the time is now, and all the technologies that we need to do it are now. However, if we do it in places where the grid is so dirty, like Alberta, and we transition everything to electricity while the grid is still dirty, we're not reducing carbon emissions. If we're doing it in Quebec or Ontario or in BC, we are. So it's really important to understand where your electricity comes from and how it's generated. And I always like to play with these quotations, and I see one extra word in here. I just say electrifying construction, because at the same time we're going to construct 5 million new homes, we're going to be retrofitting to net zero 16 million existing homes. We need to electrify everything, not just the new construction. New construction represents about 3% of all construction. Okay, so in our workshop with the federal government, we invited local builders, architects, developers building subdivisions for, you know, these home buyers of the future. The municipality was at the table. Utility reps are there, and key technical reps, energy advisors, modelers, those types of people. And so when I think of sort of the Save the Planet team or the low carbon building team, we have sort of the traditional trades here. And those of you are in this thing, you largely fall into the architecture realm. Often the architects are the lead consultants. And historically, you would work with structural, mechanical, construction managers, civil engineers on your site planning, electrical engineers. But now we have all these other people, engagement professionals, energy modelers, building envelope consultants, because you'll see one of the ways to reduce peak demand on our grid is to re-engineer the building envelopes, not only for all the new homes that we're building. Those are the 7 new wall assemblies that were just recently published that I'll share with you at the end of this presentation, but it's also to retrofit existing buildings. We need certification professionals. Maybe we're going for a LEED Gold or Platinum. We need a LEED AP. Maybe we're doing a net zero construction or a passive house. We'll need those respective experts. Sustainability consultants, renewable energy. has to be part of each and every project that you touch forevermore, now and into the future. And even if you're not putting renewable energy on the roof of your building and you're doing retrofits that affect the roof of the building, put on a high albedo or a white roof, a vegetated roof, and run conduit from the roof to the electrical room so that when solar does get installed, you'll look like a genius. On the grid side, well, it's getting a bigger and bigger demand. What's going to be required in the future is more and more. If we're going to have more demand for energy, how that energy is made. And here, this is really just showing you where it's used. So the residential sector is this one. Ag sector, I believe, is this one. Commercial sector, so the ICI, which we also work in ICI and residential. And the industrial, by the way, we also build industrial buildings, and other demands in general are increasing. So we're going to need more of it. Maybe we can use what's generated more efficiently. This is kind of an interesting case study in the same study for distribution system operators. Is over here on the left, you have a case. So it says case 1 assumes that the resources stop supplying electricity once their contracts expire. So we currently have contracts to purchase electricity off of, say, nuclear power plants. They were designed to operate for 30 years. Many of them are in their 40th or more years of operation. If we stop being able to utilize those, or they start blowing up on us, our ability, if this dark line is our demand, our ability to generate to meet the demand gets further and further away. The second case isn't quite as gloomy, as this is assuming that we can continue to operate our nuclear power plants, but you can see in the future, we start to get further and further away from generating what it is that we're going to need to utilize as a society. This grid I just put, or this slide I put in just to show you that this isn't a straight line, okay? It's a very dynamic system. As solar, a cloud goes over a solar field somewhere, and the wind dies down somewhere else, but the wind picks up in a third-party location, and the sun goes from cloudy to sunny. There are all of these inherent mixes. What we need to have is a base load. You can see here, I'll draw a sort of a straight line. If we have a base load, and if our nukes can produce this amount of energy, and they run 24/7, all year round, that covers that. Well, what about when we turn on a light in the middle of the day, or things get busier, we have air conditioning demands? This stuff is usually made up with those gas plants that spin up, and the smaller pieces often are made up with renewables historically, okay? That needs to change. I recognize that I'm here talking to Ontario architects, so I thought I'd just take a little bit of a deeper look at the grids as they break out in Ontario. So we're in the southwest grid in London. If you're in Windsor or Sarnia, you're west, Niagara, very first power plant on Earth. GTA, etc. Okay, Ottawa kind of stands alone, and then of course Northwest Ontario. This I thought was a very interesting dynamic. So the Bruce up here, basically not too far from where my farm is, up here in the pristine countryside of Ontario, this shows you that this is how much electricity is being generated in the Bruce grid. This little red X is how much is needed to satisfy the electrical needs for the Bruce Peninsula. What does that tell you? A vast majority of the power generated in the backyard of this farm is nuclear power destined for Toronto. Since we're all occupants of Ontario, I'll also mention that the Bruce has also applied and is moving on to the next stage of approval to permanently bury nuclear waste right adjacent to the Great Lakes, which represents 20% of the world's fresh water. And we have over 30 nuclear plants on the Great Lakes Basin already. And that's my rant on nuclear. Sorry, but it's a necessary thing. The Eastern districts, you can see they're generating basically what they're consuming. ESSA, not quite there, but that's why you see all those wind turbines there. Niagara is generating about twice as much as what they need. Again, the surplus goes to Toronto. Northeast, they're generating pretty much what they need. Northwest, the same thing. Ottawa, no generation, but they have demand. And look at the GTA. Southwest we demand this much, we generate this. West, that, and that. GTA, again, pretty much generating what they need. I thought it's important for you to understand sort of the spatial differences just within Southern Ontario. And then we start looking at emission factors. So the amount of electricity we use, if we know how much electricity we use, we know how many grams of CO2 are being generated per kilowatt hour. Remember those efficiency factors? And here it shows between 25 and 90 grams. I'll decipher this a little bit to you. So summer peak hours. So from midnight, typically around, let's call it 3:30 or 4 in the afternoon, we reached our peak demand on the grid in the summertime, largely driven by cooling. And in the winter, ironically, we hit our peak demands roughly around the same time because people are coming home, turning on the lights, having their dinner. And as we transition more and more heating systems to electric, we're going to see increase in electrical demand during those hours. So back to the peak. So why do we want to do this? Less strain on the system. So if you can imagine that we're delivering water to put out a fire and we need to fill up an entire pipe to put out that fire. So if we can't fill the pipe up, we can't get enough water through the pipe to put out the fire. The same thing applies to electrons moving through a wire. The wire is only so big. Think of it as a pipe. We can only push reasonably so many electrons through that pipe at any given time. Sorry about that. That's the doorbell at my home in London ringing. Gotta love technology. Okay, so this peaking generation capacity, which is usually starting up those natural gas power plants that are usually sitting by idle until we need them, then they start to spin up. That's what the Premier was talking about. It takes about 2 hours to spin those up. We can lower the cost. What cost? All costs, capital costs for the supply and the demand side. We can reduce sizes of transformers, feeder lines, substations, and other equipment, i.e. we can transition to cold climate air source heat pumps. Prior to that, ground source heat pumps were sort of the leading horse in the race. Now we can harvest heat from air efficiently down to minus 20 degrees C. And if you look at those temperature maps for the future, especially if you're in Southern Ontario, the days below minus 20 in the future are greatly reduced. So that means these technologies are awesome today and even more awesome in the future. So by doing this, we can lower our operating costs, time of use billing. So we pay more when more electricity is demanded. Why? Because it costs more to produce it, and it's less efficient to do that. So by lowering these peaks, we're lowering emissions overall. We can have community scale savings. We can have provincial scale savings. We can have national scale savings. And then lastly, these small peak reductions across the multipliers of 16 million homes adds up to a huge reduction on burden on the public infrastructure to service those 16 million existing homes. This slide I wanted to include just to give you a general feel for or, devices that we would currently use or come across and can compare them. So we have a 100 amp panel in our house at 240, so 2 phase, which equals 24 kilowatts of peak capacity throughout the day. So these heat pumps, which are awesome, can demand between 3 and 15 kilowatt hours. Baseboards will be more. Hot water, heat pumps between 4 and 5 kilowatts, tankless water heaters 4 to 15. Notice you don't see a traditional electric hot water tank here or a traditional natural gas hot water tank. Why? Because they're both wasteful and have increasingly high carbon emissions associated with the grid electricity they require to operate. Level 2 charger for your electric vehicle, 6 to 12. In the future, we're somewhere between 3 and 19, depending on the way the technology goes. Air conditioning, traditional air conditioning, 2 to 5 kilowatts. Now, if we combine that with heat pumps, we get to reduce it on both the heating and the cooling side. And then our plug loads, our occupant loads, somewhere 1 to 3 kilowatts. So you can see it doesn't take long to hit up or add up to your 24 kilowatts of peak power. So again, another way of showing that, I talked about the nuclear. So the base load runs 24/7. Niagara Falls, the water runs over the falls 24 hours a day, 365 days a year. That electricity off of that generating station contributes to Ontario's base load. Intermediate loads are, where we start spinning up these natural gas. Also, I should have mentioned renewables. Kind of, they could make up part of the base load, but they tend to find themselves mostly servicing intermediate load because the base load's hard to turn off or to trim back. And then ultimately peaking, maybe we need to turn up our gas plants on high to get that dinner time in the winter, or sort of 3 or 4 in the afternoon in the summertime to make up that extra demand. Again, the goal of this exercise is if we can reduce what we'd call the peak demand, if we can reduce that by 50%, a whole lot of the problems that we're facing today don't disappear, but we're able to manage our way around them without having to build a new grid and running the risk of the cure killing the patient. EVs, suffice to say, we're going to have more and more of those. And here we go, 7 kilowatts typically, but as high as 20. I think I said 3 to 19 in the prior slide. The duck and the falcon curve are important for us to understand. The duck curve is basically daily curve. So we have a kind of a continuous demand. The sun comes out typically, and this is years. In 2018, we needed this much peak energy. 2024, because of changes in technology, we need this much energy. However, we still have these peak times a day around 6 p.m. at night. Even those, are actually getting worse. The midday is getting better as time goes on. These peak areas are getting worse as time goes on. So that's over a 24-hour day. And then the hawk or falcon curve here shows over a year. So over the course of a year, we have high demands in the winter, lower demands in the shoulder periods, a peak in the summer for cooling, another lower period in the shoulder months, and then peaks in the winter. This is what the grid sees. So again, what our goal here is from the demand side is reducing these peaks that the grid is seeing. By reducing the grid peaks, the grid is happier, and we're able to save a ton of money doing so. So we're going to look at key barriers that builders have brought forward. And we're going to talk about occupant loads, these demand electrical panel upgrades. There are smart panels I'll show you on a slide or two here that we can use to reduce peak load. Okay, one of the things that we can do to reduce peak load is actually store the energy where we make it. Electric battery storage from solar installations, much like the one that I'm speaking to you from today, coupling that with heat pumps, we can run and operate our systems. Our early heat pumps, large heat pumps caused voltage disruptions. Guess what? The heat pump industry has gotten that memo and it's being worked on. We also need to consider sub-metering. Maybe we just want to meter tenants. Maybe we don't even need a grid. I love this picture. This is 6 kilometers from where I'm sitting today at the local Canadian Tire. We have a lot of Mennonites in the area, so they have horse and buggy parking only. And over here you have EV parking only. There's about 20 Tesla fast chargers right next to the horse and buggy parking. I thought, what a beautiful world I live in, right? So EV charging are really our new loads. Why? Because it's a new technology and we've been calculating them as 100% load between 40 and 80 amps. If you have a 100 amp panel, that's a problem. So that forces upgrading your base panel to 200 or even 400 amp panels. Well, through the electrical code exemption, and if you have an energy management system, your EV charger can count as 0. And the reason is if you plug in your EV during peak times, it's not going to charge. It's going to say, hey, your hot tub is running now. We're going to heat the hot tub. And when the power is cheaper, we're going to run your electric car or charge your electric car. Local utilities are key enablers. The problem is every one of us works with a different local utility. Engage with them early and often, okay? And you know, make sure you're electrical consultants, and I'm not an electrical consultant. None of this is intended, as Felix indicated, to be engineering advice. It's just insight, hopefully. So cost to put in a 400 amp panel, not insignificant, 10 grand. For half of that, about $4,000, I can put in something called a smart panel, where every circuit breaker has a computer built in and it can juggle the loads within the panel itself. How we can stay under 400 amp panels? Efficient homes, okay? That means the wall assemblies need to be thermally efficient with these load management systems. So here, you know, this establishes a priority. I have my roast in the oven and I plug in my electric car. Guess what? The roast is getting the power. Again, the electric vehicle, it can switch between, you know, sources to decide when I'm going to charge that electrical vehicle. The total load of the whole home comes down. These systems cost, let's say, $1,000. The utility saves money. You save money because you're purchasing off peak hour and you're driving. All your utility bills are driven based on your peak usage, so you can cut your power bill in half. So we're switching between these large loads based on a predetermined logic that you program into the system, or your consultant programs into the system. Hydro-Quebec data shows that for actual real panels, when they measure the power going to them at peak, is about half of what they thought it was. Canadian Home Builders Association, Electricity Canada, BC Hydro are all working on this to get actual load calculations from homes so that we can determine what these short-term peak loads are and what the size of panel would be adequate to make that up. This is just showing you the changes. If this is our peak up here, and these blue lines are all actual real measurements. So this is what the grid thinks we need, and they're generating that much, and we're only actually requiring half that. It's not efficient for anybody. So as we move forward and the electrical consultants start tweaking and negotiating with code authorities, we might be able to soften some of the language. So, you know, to wrap that thought up is we want to think about barriers, gaps, opportunities. Einstein once said, in the middle of difficulty lies opportunity. I talk to students a lot and I twist that quote around and I say, well, according to Einstein, we're living in the most opportunistic time in human history. It's also the most difficult time in human history. We want to look at these technology approaches, make sure we're comparing apples and apples. And what are the apples? Carbon to carbon, okay? What ends up in the atmosphere that is causing the degradation of our planetary system. Make some choices. Some are more appropriate in Ontario than Alberta. Some are not. So this is what a workshop looks like, where we get together with real people. This individual here is Doug Terry. He's built more net zero homes as a small builder in Canada than anyone. So we get together with builders and developers and consultants, and we talk about things. The tiered energy codes, the national building code, we consult and we advise on all of those well in advance of them being promulgated. The model is listening, building the resources, delivering a solution to industry, and then trialing it and sharing it widely. Here in Durham region is the most recent workshop that we've had. So we've identified the technologies, we've worked with groups. We have manufacturer challenges. We go, here's the problem identified by the technicians across the country, manufacturers, what is it that you can do about it? Then we work with partners to get solutions, prepare regional case studies, and then we go on to do it for another region. That could be done for a region near you. Residential heat pumps, we've developed a whole array of videos, apps are in the works, workshops ongoing, how to size, how to train, how to install these new systems. Why? Because they're new systems. They're not difficult, they're just different and require some unique training. This is the electrical smart panel I referred to earlier. So for about $4,000, you can see it looks like there's a little computer screen here on every breaker because there's a little computer at every breaker. So this will save you about $1,000 of avoided costs on peaks. Not sure who should pay. You're really saving the grid money, but right now the developers are paying or the homeowners are paying. Grids are not set up as a push-pull technology yet. Maybe we don't ever need to. Maybe we can put enough battery storage out and distribute it so that we don't need to do anything to the grid. Doing nothing is always an option too, as long as we get to zero carbon. We don't have historical data for all electric communities under these systems. Why? Because they didn't exist in the past with EVs. So industry says there's too much red tape. It delays permits up front. If you want to use something new, we need some sort of compliance pathway, a trail of breadcrumbs to follow. We need to push back and communicate with utilities. We need to negotiate these additional costs and allocate them. Hey, utility, we're saving you money here. Why is this costing us extra? And what we found out historically is it burned the eager developers, and the slow adopters were able to benefit more. Cost-effective pathways to electrification exists. You just need to navigate them with your consulting, low carbon consulting team. We have procedures for builders to follow, checklists. We need to deal with these issues right at the land planning stage so that we can optimize solar, rooftop solar as an example, distribution systems, maybe shared ground source heat pumps. Building inspectors, provincially, nationally, need to be part of the process because they're part of the solution. And we do mock-ups, wall assemblies, so all of these learning guides, we building actual models and take them around the country. Some quick modeling that we've done using those tools through LEAP. So a code compliant home without an electric vehicle requires this much energy, let's say on peak. Code with electrical increases. If we go all electric home, conventional all electric home with a EV, you can see what that does to the peak, runs it up to 9. If we can cut it off at 4.5 using technologies, it's still very much doable, not radically different from code compliant. By the way, code compliant doesn't mean zero carbon. Code compliant is the crappiest house you can build that doesn't land you in jail, okay? You're doing SB 12 calculations. You're not doing, the heat loss, heat gain, room by room calculations. Peak loads, again, it's important to know what's using the peak loads. Here we can see hot water, electric resistance heating, and or electric resistance or peaks. So if we focus on those peak loads, they're about 1% of our entire demand. Tools in our toolbox that we're using and that I've used already in my research: super insulated, I call them deep energy retrofits, or we call it also net zero new home. Cold climate air source heat pumps without low temperature backup. This is what that means. Oftentimes they are gas or electric resistance. A dual fuel heat pump in places like Alberta, it makes sense. So when it gets extra super cold, a little bit of natural gas is used. And the reason that it makes sense in Alberta is because their electricity is so dirty. Ground source heat pumps, 80 US gallon heat pump with water, heat pump water heater. So it takes heat out of the air in the mechanical room, heats your hot water. Battery storage, solar PV should be on everything you do, or at least capabilities for solar PV in the future. Smart chargers, again, to reduce that panel size and peaking. Smart splitters, load control switches, and that smart panel that I showed you. And here's another one with the app, so you can see exactly what's going on. Some of these technologies with peak demand savings shown here between, let's call it sort of 10 and 20% peak savings and incremental costs to do those upgrades. We can run these models. I can show you how it's done, but that's probably a topic for an entirely different lecture. And again, panel saving technologies are sizing. So we can go with the smaller panel, oftentimes leave 100 amp panel in there. Technologies, EV charger with dynamic load balancing, $1,000 investment can save you 30 to 60 amps on your panel. A smart splitter, 30 to 50. Load control switch, again, the incremental cost for that. Savings, the smart panel, incremental cost, and virtually unlimited amount of load that you can run through them because you get to program when it's on and when it's off. Combinations of systems. So here we have combo one. So this is a dual fuel air source heat pump. So the Calgary scenario, heat pump, hot water heater, and load control switches. We can reduce our demand by 56% for incremental costs of $2,400. So on and so forth. If we go zero carbon, this has carbon in it, right? We have to get away from carbon. So we can go to cold climate air source heat pumps, load control switches, a little bit more money, slightly less peak demand, but still better planetary outcome. And we can also add battery storage. And by the way, that price is decreasing almost hourly. Other insights: panel sizing technologies are a standard part of Section 8, the Canadian Electrical Code, and can be applied readily. Energy management systems in the code draw the attention of your electrical consultants to that. We can put in batteries in a 1 hour fire rated room. That does vary by jurisdictions as per ESA bulletins. Again, get up to speed for that for your projects. Is there net metering? Maybe you don't need it. Dual fuel, net zero homes. We're at a cost disadvantage because they couldn't sell electricity back to the grid if they don't have net metering. And what we found in Durham in particular, that Hydro One had already maxed out its ability to accommodate renewable energy. So we'll have to wait until sometime after 2030 to be able to accommodate any more renewables. Next steps, more of what we're doing today, right? All boats rise with the tide. We want to share information. Heat pump, hot water heaters, envelope measures. And by the way, I've done 5 different envelope assemblies, and we're collecting 150,000 data points every 24 hours. And in a year, I'll have the results for that. Green development incentives. Maybe there are some local ones. Electrical safety authorities and the Ministry of Environment, and how we can mitigate these peak loads. and also expand our analysis of upstream and downstream energy requirements. So to wrap this up, code no electric vehicle, code with electrical vehicle, a zero carbon home. These are a carbon home, a reduced carbon home, greatly reduced peaks. These are zero carbon options with greatly reduced peaks. So that brings me to questions, and I'll just point out in the final slide, we have a little scan code here that you can scan to get access to this URL, which will bring you to the brand new Leap of Wall guides that are less than a couple weeks old. And you know, this is not engineering or architectural advice. So with that, I'm going to come back to my computer and stop sharing the screen. Oops. I want to stop sharing the screen in a minute. All right. I appear to be back. So I see there are some questions. Let's take a quick look and we'll try to get through them here. So why are you not superimposing the radius of the sun is increasing on your climate change model? Why do you think the surface temperature of Mars is going up? And there's no humans causing pollution on that planet. Why are you not superimposing effects of volcanoes and wildfires on our graphs? Because they're insignificant, okay? And I sense that, William, that you haven't really been told the climate story. You might want to Google the Climate Reality Project. Climate Reality Leadership Corps. We recently trained professionals in New York City. We travel the world. We've trained over 20,000 people so that you will have all of those answers. I can't take the time to try to dispel that. That's a 3-hour lecture, and suffice to say, those are non sequiturs. They will not affect anything that we're doing or talking about here today. Ryan says, with premiers in provinces such as Ontario and Alberta with contradictory approach to the federal government or even UN policies on the environment, how do we adapt? Yeah, positive changes. Well, my approach is bottom up. Guess what? You guys aren't the premiers and gals. You're practitioners. You are where the rubber meets the road. If we're ever going to save this planet, we need each and every one of you to understand what the problems are, what the real problems are, and what the real solutions are. And you also need to recognize that they all exist today. I didn't talk about anything that we're hoping for or wishing for or looking forward to happening. Coordination of all these things, I just tried to put it as it's not Canada, it's not Ontario, it's not Alberta, it's the whole frickin' planet, okay? And if we do everything here and India decides to forget about it, we're all gonna bake. You know what? India and China are leading the charge. The #1 emitter of carbon on a per capita basis on Earth today, and has been for the last decade, is Canada. A lot of people don't know that. Can you please explain the environmental downsides of nuclear? Yeah, two. One is the embodied carbon, one of the dirtiest construction materials from a carbon perspective, the embodied carbon that we use. Two of the dirtiest materials are used to build nuclear power plants, concrete and steel. And those emissions that they're showing for nuclear plants have not factored in that carbon emission that's there for 150 years. Why? Because they didn't know how to do it when they were built. We could probably back calculate that and it would be terrifying. The other problem that I have with nuclear power, and I mentioned that Bruce now wants to bury nuclear waste beneath pristine farmland adjacent to the Great Lakes. Those materials will kill human beings for 600 million years. That's the half-life. So they'll lose half of their concentration in 500,000 years. This project has a lifespan, I think, of 10,000 years. Doesn't add up. We have not treated or rendered benign a single gram of spent nuclear fuel. And we have enough plutonium, the byproduct of nuclear power plants, to kill every man, woman, and child on Earth 6 million times over. Those are a few reasons. I've never heard any of those arise around solar panels, as an example. And I'm not here to offend anybody. If you work in the nuclear power sector, God bless you, right? And we did what was the Royal We as a planet did what we thought was the right thing, in the 60s. It's an interim, maybe positive stopgap, but maybe not the end game. Thank you for sharing my rant on nuclear waste. This is the next one, so there you go. Very important. The public's got to be engaged. I'm one person, right? Now there are, I think, roughly 262 of us. We can just amplify my simple little message by 262 times. Stan goes on to say, it seems like nuclear is the latest debate in power generation. On one side, nuclear is the only solution, and the other side is heavily against it. I would be all for it if that was the only solution, but it's not. I.e., nuclear may be called clean, but the waste is a problem, and it only gets worse. You're absolutely correct, Stan. There are some countries dedicated towards being completely nuclear free and appear to make a good case for it. And I don't think a nuclear plant's been built in 30 years on the planet. And I suggest that that's probably a reason why. My presentation is compelling and believable. Thank you. And, yeah, these peaks are what you need to be thinking about. You don't need to be an electrical engineer to understand that the peak is the problem. It's the size of the pipe, right? Do I have any sources that could be used, just quick references, to help push the pro-electric grid without nuclear? Again, I would steer you toward the Climate Reality Project here in Canada, the Climate Risk Institute. I've been engaged with training construction associations across Ontario. The Canadian Green Building Council, I've trained professional engineers on these topics across Canada. And now I'm talking to OAA, obviously across Ontario. So Grant goes on to say, given my aversion to nuclear, can we meet base and peak load demands? I think we can. Battery, solar, and wind, okay? Has COVID reduced work from the home situation, has increased home for the work? Many people are affected. Yeah, the duck curve affects you at home for sure. And, the other thing is, the pandemic made me realize that, hey, I can even educate without any wires connected to me. Yes, the presentation is being shared with you, and I believe Felix has also recorded the presentation to be shared with you. So please make reference to it. Do I think the universe is finite or infinite? Good question. I think there are likely other parallel universes that are ultimately infinite. Big question, Will. Maybe a whole another lecture for that one, but where did the gap in the panel demand factor come from? I think it's factors of safety, right? I remember getting the whole factor of safety lecture in university as a civil engineer, and we're studying reinforced concrete design on three-way slabs, and we had to calculate when they would fail. And then we'd calculate the load where they would fail, and then the professor, I remember going, that's not right. What's wrong with it? That's exactly the load. Well, we have to apply the factor of safety of 2.5. Why? Well, because when we do that, buildings don't fall down. There's no real rationale, no science behind that number. They just knew if they're cautious, bad things didn't happen. So I think it's human nature to be conservative, cautious. You don't want to burn 16 million houses down, right? And realize that you made a calculation in the wrong direction. All we're saying is now that we know more than what we knew then, let's use this new information. And by the way, these new technologies that already exist to fix this age-old problem. Thank you for the positive feedback, Thomas. First law of thermodynamics says energy that cannot be created by will or destroyed. You're correct. Second law says that it changes form, right? That's the second law of thermodynamics, which is entropy. There's supposed to be a barrier at the end of the universe that is a closed system. Otherwise, it would not work. Therefore, the universe is finite. Okay. And yeah, and it's continuing to accelerate away from us in this finite universe. I'm not here to debate cosmology or climatology, but I'd be happy to under a different format. Sun's absolutely expanding. I'll give you a little bit of information on the sun. On the sunlight that hits our planet in 1 hour is enough energy to supply everything on Earth, boats, planes, buildings, houses, everything, transportation. 1 hour of sunlight can power the entire planet for a year. That's the energy balance. And if we didn't have 10,000 times more energy than we need already raining down upon our heads at each and every building site on Earth, if we don't take advantage of that first and foremost, how smart are we, right? That energy is already here, and it's made, by the way, through nuclear fusion, not fission, that we have here on Earth, nuclear fusion, which creates no carbon. All right, so that's enough of the cosmology stuff here. Sema says, is there a coming program and subsidies to homes, homeowners, electric storage solutions? Stay tuned. Well, you know, there's an election year, and politicians are renewable resources. We need to make sure, if you feel strongly about that, that you speak about it and you vote your mind. How can one join in one of these communities and meetings to partake? Again, joining the Climate Reality Project is free. The training is free. All you need to do is get there. So we train somewhere on Earth basically every 3 months. And the training is delivered personally by Nobel laureate Mr. Al Gore. Anthony goes on to say, are smart panels permitted in Ontario? And if so, do utilities permit a smart panel to be applied to all other household equipment so that short duration critical loads such as cooking can be prioritized over less critical loads, such as hot water heating, thereby reduce the risk of loads? Also, can this be automated and set up so that users can choose priorities? Yes, yes, and yes. Okay, that's a great series of questions to ask your electrical engineer. It's my understanding that they're freely available, not widely used. That's why I'm talking about them today. I see them as a glowing example on new construction. However, for these 16 million homes that already have 100 amp panels, maybe some of these other load switches or, you know, lesser invasive things are more practical, and we're still able to achieve the same thing. Okay, so Sharif goes on to ask, would it be possible to get a legend of many of the acronyms used in the presentation so that they're looking at the presentation, have a better understanding of? A lot of the acronyms, and I apologize, this low carbon industry is rife with acronyms. I try to, every time in a presentation, I use an acronym, I try to define it. There might be a couple in there I haven't. Nothing important though, so I usually try to define it. I'll have it in brackets the first time I use it, then I'll use it throughout. But I do often, or do sometimes miss those. The QR code again, yeah, I can do that. As soon as I get my screen organized. Here you go. Okay, thanks for asking, Sarah. Thomas indicated very interesting in the envelope data research outcome on energy performance. Is it possible to share with us on that? Absolutely. When it's ready, I'm going to share it nationally. There are no secrets in my world. And I think based on initial data is that we have 5 excellent wall systems that are all performing at as designed and keeping everything dry, which is a big concern in the building science perspective. Absolutely happy to share that with you when the time comes. Please feel free to reach out. I like working with like-minded individual. So the 7 walls, Alan, are right. That's that QR code that I'm sharing with you right now. Hot off the presses, French and English. John asked, is the residential construction industry up to speed on installation of these net zero smart panels technologies, or is it very specialized expertise? I would say aspects of the residential industry are leading the charge. Others are in the dark ages, and that's why I started this presentation talking about the Wild West. As you can see, there's still people that don't believe in climate change. Sean goes on, product reps, which include engineers for a local precast company, have pitched their products to our design team as being a green option because they use concrete additives and recycled carbon. Yes, there are greener options for concrete, and if you have to use concrete, you want to get the environmental products declaration from the individual suppliers and pick the greenest option, okay? Not all concrete is created equal from a carbon perspective, although they are all carbon and positive. Some are way better than historically, though. An example, established carbon intensive construction methods attempting to respond to the climate issues you've outlined today. Can you talk about realistic or robust these claims are? And is there a reputational third party to verify? Yes, and they're called independently verified environmental product declarations, also referred to using an acronym, I apologize, as EPDs. So environmental product declarations. And you don't want a product specific EPD, you want a third party verified industry prepared EPD, which are prepared using ISO standards and then verified by independent third party. Those are your best data sources, by the way. That free software that I talked about, the government, Google this, MCE2 and NRCan, and that will give you the emission factor for 10,000 EPDs for free. Okay, Deanna goes on, as far as I can see, legislation is key. Convincing clients that with an extra price tag is tough. Yeah, but we can do it with a lower price tag too. My comments on the government can be helpful if inclined is so important. We as professionals can only educate, convince, push so much. We're looking to Germany at all for how they are implemented. Yeah, Germany is the same as us, same latitude, right? They just had a 20-year head start, and that 80% of their energy is renewable. And I think several days a year now they're 100% renewable grid electricity at the same latitude as Southern Ontario. Richard asks, when working in a dirty grid, is it recommended to design the current conditions to reduce carbon emissions, or design with the expectation that electricity production will eventually change? Yes, yes and no. Okay, so mechanical equipment has a lifetime, a usable lifetime. So if I'm installing maybe a combo system in Calgary today, I'm doing it, but I'm also designing a cold climate full retrofit for in 15 years when the grid has caught up with where it needs to be in Calgary. And, you know, by then the carbon taxes will be prohibitively high also. So you'll transition to low carbon. We do that too. Say I buy, you know, the TD Bank Tower and I want to transition to zero carbon. I don't go in there tomorrow and change everything. I go through each mechanical system. I assign a lifespan to it. And at the end of its useful life, I transition it to zero carbon. There's no point throwing out equipment because that's part of the cure killing the patient scenario. So Felipe says, how do I feel about the balance between incentives and ground up versus regulation and more authoritative approach? Will we reach our goals and putting much of that trust in free will? And Richard also touched on this, as you know, with the grid and regulations. I can tell you we have 2030 national building code pretty much figured out now. 2025 is promulgated or about to be promulgated. When I talk to the Ontario folks, it's going to take Ontario about 3 years to adopt the 2025 National Building Code that we've been working on for 10 years. Some of the delays are outside of the control of the federal government. As soon as these local jurisdictions start going, well, you know, it worked in BC, but it can't possibly work here in Ontario. We're different. And that slows down the process. So we wait an extra 3 years for it to be promulgated as law. And by then it's 3 more years out of date. So I'd encourage you to follow the code development process. By the way, the 2030 code is, I believe, open for comment now, public comment. Get your comments in there. Francis, in my opinion, which will be the driver or the incentive to encourage change, carbon tax or a significant reduction in the cost of clean energy versus fossil-based? Well, that's what the carbon tax is doing, right? So the fossil-based energy is what in economics we call an externality. You and I and every other person on the planet is paying for, you know, high carbon in the atmosphere, higher utility bills, carbon taxes, and all that. There's about 5 companies on Earth that bring all the carbon to market. They don't pay that tax. You know, we pay it. So that's called an externality. And you know, as long as they don't have to get hit with that, or it doesn't affect their bottom line, well, I think we have a real way to affect the bottom line and save money in the process. You can go entirely solar. That's something that I'm proposing for a nonprofit here in London, Ontario, to go. The grid wants $350,000 to connect. For $350,000, I can set you up off grid forever. Which one would you rather pay? Have monthly bills in a grid or no bills forever? Alejandro goes, if I had a choice, one single electrification upgrade to an existing building, which one would it have the load control switching, okay, or smart switchers? Same question for dealing with peak loads, same answer. Same answer, very quick, very easy, and you can use your existing panel. Do you have my contact info to share with the group? I'll leave that up to OAA. I'm happy to be reached and contacted. Dan is asking, is green hydrogen making any positive impacts? Absolutely. In Europe, it is. There's a 600-year-old smelter that's been converted to green hydrogen. And just so everyone knows, green hydrogen is hydrogen generated by solar photovoltaics or solar electricity. And Latimer is asking, has the work from home phenomena changed anything in the peak? Yeah, you know, no, because, you know, whether you're working in an office or at home, you're still using the energy. Where, you know, spatially distribution, absolutely. Spatially distributed should actually help the grid with peaks also, in theory. What can individuals do? For architects, buildings are not our decision or funded by us. Well, let me just indicate you're a very huge influencer, right? So we can educate, absolutely. And that's all I ask. Try to educate and go after your toughest client, right? Maybe they don't believe in climate change. Have that discussion with them. Maybe their fears are not founded, or maybe they are founded. You can say, I just sat in a lecture and it said every builder in Canada's worried about that same aspect, but we don't want to be paralytic. We don't want to stop advancing. So we're more to join again. So again, follow these code development activities, participate, advocacies, again, climate reality, climate risk, Canadian Green Building Council. And they are everywhere and often. And like I said, the first 3 months of this year, I was doing probably 30 or 40 hours of those sorts of lectures a week. Kimberly goes on to add, batteries and mining resource extraction to manufacture them have significant environmental impact. They do, but it's less than 1% of the environmental impact that we currently get from excavating coal. I do have a slide on that, but I didn't include it for timing, which I notice I'm running a few minutes late here, but I'm nearly to the end of the questions. So thanks for hanging in here. Sean asked, as the pressure to meet the housing crisis is upon us at the same time, the climate crisis, and we are going to make large investment in the building stock at the same time that we live with for some time to come. The response to one crisis is to demand the removal of red tape. Yeah, absolutely. That was one of the things identified, right? While the response from the other crisis is to build smarter. Yeah, we can do both, right? Which it implies is impose more red tape. Well, no, smarter can be voluntary, right? Net zero is a voluntary program. LEED is a voluntary program. Passive House, the voluntary programs. And they're great ideas, right? Can I comment on the importance of balancing these? Life is a balancing act. I think of it as, you know, juggling plates, those circus performers. You have several plates in the air. Maybe you'll drop a plate from time to time, but I can guarantee unless we try now to make effective change, your children and grandchildren are going to suffer beyond your wildest expectations. And I'm not here to fearmonger. This is all science, right? Hosen goes on to say, I believe this type of education should be provided for the developers and those that hire architects, and it is. They are people that should be convinced to design, and in fact, most of the developers that I'm familiar with require this of their design consultants. So if you're hired by them, they'd be questioning you about your green experience. Where the minimum cost of construction and minimum time to construction, how is it the contractors contradictions? Well, it's called the cost benefit analysis tool. And very quickly, because I know I'm really running out of time, but this is something that you'll like to see. I think I had it up on the screen. This gives us, well, the computer's going to do something else for me. What it's calculating is a Tableau database with, I think, some 10,000 homes in it that are built across Canada. And it tells you on the axis, the x-axis is energy savings, so 50% energy savings, and the total cost per retrofit. And each of these dots is a solution. So if I hold over a dot, it tells me exactly what it is: the cost to renovate, the R values, the energy systems, the above grade walls, the below grade walls. And usually when you pick a solution down here, these are the highest performing, lowest cost options. So I can click on that one. This is called a cost benefit analysis tool. And we can get that information literally at the click of a button. Nothing mystical about it. And the federal government and Natural Resources Canada has been working on it for a long time. Lucas Collada would be happy to have a conversation with you about that. So I'm just moving on to Thomas's comment. Batteries could create serious pollution on Earth. Highly recyclable. And sure, we have to excavate some lithium, but when we compare it to the amount of coal, just coal we excavate, it's a fraction of a percent of, open pit mining compared to what we're used to doing. And the final question I have here today from Molly is, for the last few years, we've been designing multi-unit affordable net zero energy housing and have really struggled to find mechanical cooling solutions that are low maintenance, intuitive for tenants, low cost, etc. There are lots of combined HRV heating cooling units available in Europe, but we can't seem to find them with affordable options here and small enough for our tiny little loads. I have the answer for that, by the way. Do you have any ideas or recommendations for the all-in-one ventilation, heating, cooling units to use in deep energy affordable rental units, mini splits that are great for end users, all compressors, tenants to lose remotes, etc. Centralized air, heat pump technology is expensive. So I would encourage you to look at cold climate air source heat pumps. For my research, we used the very first generation of what we call small equipment. One of the problems that we create for ourselves when we retrofit every house on the planet to be zero energy, we have a lot of existing small, usually social housing that also needs these upgrades so that we can go in and do these upgrades affordably. Energy recovery ventilators, we didn't talk about today. They take energy, right? However, they recover energy too. So they recover more energy than they take to operate. And the key thing about it, ERV, is ask your clients how long they want to wait for fresh air. Okay, but we have tuned in at least a half a dozen different systems with ERVs, heat pumps, dual fuel combi systems, hot water tank systems. So they're all there, all been done, all have design parameters available publicly for free. And thank you. I apologize for going 15 minutes over. Awesome series of questions.
No,
I'll
thank
turn
you.
it over to you, Felix.
No, thank you, Tom. It was great having you again at our webinar series, and thank you for a great discussion today. As we conclude this webinar, I would like to draw your attention to some announcements. The next webinar takes place next week, Thursday, on May the 16th, also at 11 a.m. under the title, Communicating the Value of Design in Architecture. As mentioned, the OAA will report your participation in this webinar to your transcript. Therefore, there is no need for individual reporting on your part. Additionally, all attendees will soon receive the presentation file via email along with a link to submit your feedback. Once again, thank you very much for your attendance. Tom, thank you very much for being with us today, and have a productive and pleasant remainder of your day.
I just have one final comment, Felix, sorry, that occurred to me. In just a couple of weeks, I don't have the exact date, but in a couple of weeks, Jonathan Schmiegel from RDH will be presenting to the OAA Live. I think it's your AGM conference. If any of you are there and participating, look for that presentation. He'll be discussing 5 wall assemblies that I've used in my research. I know there was some interest in data, and he has, the initial 3 months of data, and that will be presented to OAA Live in person in, I believe, Toronto in a couple of weeks.
Great, Tom. Thank you very much for the advertisement. And yeah, I encourage our members to attend that session as well. Thanks, everyone. Bye-bye.